Good morning. In the last class we were discussing the exercise part, that is the question answers that is present in the textbook. So we reached the exercise part, that is we reached the third question that we have already discussed. Then the fourth one, the fourth question: which one of the following types of medicines is used for treating indigestion? Which one of the following types of medicines is used for treating indigestion? So the options given: antibiotic, analgesic, antacid, antiseptic. So you know the answer, that is antacid. Antacids, which are the antacids that we are using for indigestion? We can use sodium bicarbonate, and we can also use milk of magnesia. All these are antacids. That is, antacids, they neutralizes the excess acid that is present in the stomach. The person who are suffering indigestion and ulcers, also we are using antacids, isn't it? Then so in antacid, what is the action of antacid? That that is the excess acid that is present in the stomach. If we are using sodium bicarbonate, NaHCO3, which is the acid that is present in our stomach, that is HCl. So what happens here? What are the reactions taking place here? It forms salt plus H2O plus CO2. So sodium bicarbonate is an antacid, plus HCl gives sodium chloride plus H2O plus carbon dioxide. So by using sodium bicarbonate, they get relief from the indigestion. Okay. The next one: write word equations and then balance equations for the reactions taking place when A. dilute sulfuric acid reacts with zinc granules. Second one, dilute hydrochloric acid reacts with the magnesium ribbon. Then C. dilute sulfuric acid reacts with the aluminum powder. And D. dilute hydrochloric acid reacts with the iron filings. So the first one, write the word equation and then balance equations. You have already studied how to balance a chemical equation, that is in the first chapter. So the reaction between dilute sulfuric acid and zinc granules, I think we were writing this. So the first reaction between zinc granules and dilute hydrochloric acid. So zinc granules, zinc plus dilute hydrochloric acid, that is HCl. Then so the reaction between metals and acid. So which are the products? One of the product, which gas is liberating, that is hydrogen gas. So zinc plus HCl gives zinc chloride plus H2, that is metal salt. Metals react with the acid, it form metal salt plus hydrogen gas. So this is not balanced equation. One zinc. So here 2HCl, Zn plus 2HCl gives ZnCl2 plus H2. This is a balanced equation. That is first one. And the second one, dilute hydrochloric acid react with the magnesium ribbon. So magnesium ribbon, the reaction between magnesium and HCl, Mg plus HCl gives, it is also magnesium chloride plus H2. Here also 2 molecules of HCl. Then C, the reaction between dilute sulfuric acid and aluminum powder. This is aluminum powder and dilute sulfuric acid. So aluminum, we know Al plus sulfuric acid H2SO4. So first we are writing the that is aluminum, symbol is Al, then sulfuric acid. Then here also metal salt plus hydrogen gas. So aluminum sulfate, that is the metal salt. You know what is the formula of aluminum sulfate? Al2SO4 thrice. Sulfate, sulfate 2 minus Al 3 plus. So the valency of aluminum is given to sulfate, and the valency of sulfate is given to aluminum. So Al2 and sulfate 3. So Al2SO4 thrice plus what? Hydrogen gas, H2. Now here there are 2 aluminum, here only 1, so we put 2 Al. Now aluminum is balanced. Sulfate is here 3, here only 1 sulfate, so 3 sulfate. So 2 Al plus 3 H2, so 4. Then here how many H2? Hydrogen is here, only 2 hydrogen atoms are here. Here 3 into 2, that is 6. So how? 3 H2. Now it is balanced. Okay. Yes. Then dilute hydrochloric acid react with the iron filings. Dilute hydrochloric acid react with the iron filings. So iron filings, that is iron plus dilute hydrochloric acid. So we get FeCl2 plus H2. So 2 HCl. Okay. FeCl2 plus H2. So these are the balanced chemical equations. Zinc chloride. Okay. Then we move on to the next question. That is compounds such as alcohol and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove it. Compounds such as alcohols and glucose also contain hydrogen. We know both alcohols and glucose, they contain hydrogen. You know what is the formula of glucose and what is the formula of then any alcohol. Take an example. See, glucose, that is C6H12O6. This is the formula of glucose. So here there are 12 hydrogen atoms are there. Even though it contains hydrogen atom, it is not, they are not showing any acidic property. And then any alcohol, for example methanol, this is the formula of methanol, CH3OH. So it contains 3 plus 1, 4 hydrogen atoms are there, but they are not showing any acidic behavior. So here the question is, they contain hydrogen but are not categorized as acid. Describe an activity to prove it. So we know that acids, they conduct electricity. Why? Because they contain ionizable hydrogen atom. But here there is no ionizable hydrogen atom. So how can you prove this, that they are, so what is write an activity to prove that they are not acids. So when we pass electricity through acids or aqueous solution of acids, they conduct electricity. But when we are passing electricity through either through glucose or alcohol, they are not conducting any electricity. Why? Because they are not containing any ionizable hydrogen atom, or they are not containing any ions. So if ions are there, these ions are responsible for conducting electricity. So that is why they are not conducting electricity, and they are not showing any they are not having any ionizable hydrogen atom, and that's why they are not acids. Okay, but acids, when we dissolve in water and when we conduct electricity, when we pass electricity through that aqueous solution of acid, they conduct electricity. Why? Because they contain ionizable hydrogen atom, H plus ions. Then why does distilled water not conduct electricity whereas rainwater does? Here also the same reason. Distilled water is a pure water. They are not containing any ions. Distilled water is a pure water. They are not containing any ions, and that's why they are not conducting any electricity. But in the case of rainwater, rainwater may contain different types of acids, and that acids give ions. When they are dissolved in water, they give ions. But in distilled water, it is a pure water. It does not contain any kind of ions, and lack of ions are responsible for the non-conductance of electricity in distilled water, but here in rainwater they contain many acids. So acid ions or different types of ions are there, so these ions are responsible for their conduction of electricity. Then why do acids not show acidic behavior in the absence of water? See, all these are related questions. Why do acids not show acidic behavior in the absence of water? Because only in presence of water they are ionized, they get ionized, and because of these ions, because of the presence of ions, they are showing what acidic behavior. In the absence of water they are not showing any acidic behavior. That is while discussing the your chapter, so we were discussing that we have already studied that dry HCl gas, when we when there is evolution of HCl gas, when we place a wet paper, so that dry litmus paper and a wet litmus paper. So dry litmus paper, there is no action or there is no color change, but wet litmus paper they change their color. So that is because of the presence of water. So only in presence of water they ionized. Then 5 solutions A, B, C, D and E, when tested with a universal indicator, showed pH 4, 1, 11, 7, 9 respectively. Which solution is neutral, strongly alkaline, strongly acidic, weakly acidic and weakly alkaline? So here universal indicator, I think we didn't mention about universal indicator. Universal indicator is a mixture of indicators. They are produced by mixing many indicators. So that is impregnated in a strip. So in that strip is used for measuring the different strength of acids. Even though that is one acid, the same acid, they may have different concentrations. So based on the different concentrations, they have different values of pH. So that is also used in pH paper. That is used universal indicator. That is used that contain that universal indicator is impregnated on a filter paper or in a strip, that is used as universal indicator. They have different color codes are there. So that color codes will give you the value of pH of that particular acid. That is single acid, same acid, they may have different values. Why? Because that depends on the strength of the acid. So that is universal indicator. So in this the pH value is given 4, 1, 11, 7 and 9 respectively. So here 5 values are there. So which one is neutral? Which one is neutral? So we know that if the pH value is 7, if the pH value is 7, that is neutral. For neutral substances, the value of pH is 7. So here it is given A, B, C, D, E. Here which one is 7? That is D, option D. So D, that is neutral. The neutral pH 7, that is D. So D is neutral. And second one, strongly alkaline. Strongly alkaline means if it is strongly alkaline, the value of that is 0 to 14. In between, if it is 14, if near to 14, that is strongly alkaline. Here in this the value is given 4, 1, 11, 7, 9. So 11 will be strongly alkaline or basic. Alkaline. What is the difference between alkali and base? So what is alkali? Alkali are the bases which are water soluble, and bases, all bases are not alkalis. Okay, all bases are not alkalis. So strongly alkaline, that is pH 11, that is C. C is the strongly alkaline. Then for strongly acidic. Strongly acidic, here which is strongly acidic, if the pH value is very less, low pH value, they have a high concentration of H plus ion, and that will be strongly acidic. So here the pH among these 1, pH 1 is strongly acidic. So pH 1, that is C, pH 1, that is strongly acidic. Let's see here, B is the answer for third one. And then weakly acidic, so that is near to 7. Which one is there? That is below 7 and near to 7, that is weakly acidic. So here it is 4. So 4 is what? A. So A is the answer for fourth one. And for option E, which is the answer, weakly alkaline. So weakly alkaline means that is near to 7, greater than 7 and near to 7. So which one? That is 9. So 9 means that is option E. E is the answer. So these are the values. Then equal lengths of magnesium ribbon are taken in test tubes A and B. Magnesium ribbon in test tube A and B. Test tube A and B. Equal length of magnesium ribbon. Hydrochloric acid is added to test tube A, while acetic acid is added to test tube B. So in test tube A, HCl is added, and here acetic acid, CH3COOH. Then in which test tube will the fizzing occur more vigorously, and why? We know among these acids, that is hydrochloric acid and acetic acid, which is having more strength, which is stronger acid, HCl is stronger than acetic acid. Acetic acid is a weak acid. How can we say that it is weak acid? Because here the rate of dissociation is very less, but as compared to HCl, they undergo complete ionization in strong acids. And so here A is in test tube A, magnesium react with HCl. So here magnesium plus HCl, these give MgCl2 plus H2. So this is the reaction that is happening in test tube A. And what about in test tube B? Magnesium react with the acetic acid, CH3COOH. So we get magnesium acetate, CH3COO, twice Mg plus H2. So here this is the reaction that is happening in test tube B. So why the fizzing is, what is the question? In which test tube will be the fizzing occur more vigorously, and why? Because the fizzing will occur in test tube A, because it is a stronger acid. It reacts suddenly, and it gives H2. But here the rate of dissociation, that is in the case of weak acid, since acetic acid is a weak acid, that reaction will occur slowly, and hence the fizzing will be very less as compared to in test tube A. Okay. So if these kind of questions are asking, you can also write the balanced chemical equation of that particular reactions. Okay. Then question number 11. Fresh milk has a pH of 6. How do you think the pH will change as it turns into curd? Explain your answer. So fresh milk has a pH value of 6. So pH value 6 means it is slightly acidic. So how do you think the pH will change as it turns into curd? So the pH may change when the value of milk, the pH value of milk is less than 6, then they are converting into curd by the production of lactic acid, because in curd it contains what? Lactic acid. So this lactic acid, because of the presence of lactic acid, the milk changes into curd. So here explain your answer. So when as the pH value decreases, as the pH value become less than 6, if it is less than 6, so it means the concentration of H plus ion increases, the concentration of H plus ion increases and become more acidic. It means the lactic acid production will be more, or more amount of lactic acid is forming, and then it will be changes into curd. So during the formation of curd, the pH value decreases. It means the concentration of H plus ion increases and it become more acidic. So that fresh milk will change to curd. Okay. Then a milkman adds a very small amount of baking soda to fresh milk. Why does he shifts the pH of the fresh milk from 6 to slightly alkaline? So a milkman adds a very small amount of baking soda. What is the purpose of adding this baking soda? You know, we have already in this question, the previous question, we know that the pH value of milk, fresh milk is 6. So when we are adding a small amount of baking soda, and that lactic acid neutralizes by the addition of what? Baking soda. So that baking soda neutralizes the excess formation of lactic acid, and hence that will extend the formation of or it will take more time to form from milk to curd, or curdling process. Curdling process will slow down when we are adding baking soda into the fresh milk. So by adding baking soda into the fresh milk, that will slow down the process of curdling. So that's why the milkman they add a very small amount of baking soda into that solution, into that fresh milk. Then why does this milk take a long time to set as curd? This one, as I told you in this, because it will take more time. Why? Because when we are adding baking soda into this milk, the pH value increases. It becomes greater than 7. So if there is lactic acid, that lactic acid neutralizes baking soda neutralizes the lactic acid, and hence it will take more time to set as curd. So that is the reason. Then plaster of Paris should be stored in a moisture proof container. Explain why. This question already we have studied in the, that is, I think one of the question was this. Plaster of Paris is it captures moisture from the atmosphere. So it is highly sensitive towards the moisture. So it captures or it absorbs moisture from the atmosphere, and they converts into a solid mass, that is called gypsum. Equation also we have written, that is what is calcium plaster of Paris, CaSO4 half H2O, that is calcium sulfate hemihydrate. It reacts with the water molecule and it forms CaSO4 to H2O. This is called gypsum. So that's why plaster of Paris should be stored in a moisture proof container. Then what is neutralization reaction? Give 2 examples. So there are many examples for neutralization reaction. What is neutralization reaction? Acid react with the base to form salt and water. That is called a neutralization reaction. So you can write many examples. Okay, write any examples you can write. Acid react with the, for example, base KOH is a base, react with the acid HCl, gives KCl plus H2O. This is a type of neutralization reaction. Then NaOH plus HCl. Okay, take another example. Calcium hydroxide plus HCl gives CaCl2 plus H2O. So here you can see this is a base, this is an acid plus base gives salt plus water. That is called a neutralization reaction. Okay. Then give two important uses of washing soda and baking soda. So while discussing the some of the compounds, so that salt, so we were discussing the uses of that washing soda and baking soda. Washing soda is used for in order to remove the hardness of hard water can be softened by adding washing soda, and also it is used for in the preparation of washing soda, where we are using in the manufacture of soda ash, that is also used. Then what is the use of baking soda? Baking soda is used is an that is it is an antacid, and also it is used for the preparation of instant production of carbon dioxide in fire extinguishers, in fire extinguishers. So these are the questions. Then in addition to this, there are many other questions that we will discuss later. Okay, so that's all. I hope you are all following all these questions. So you just write all these questions in your notebook and find out the answers. I have already discussed the answers. So, and the other questions, apart from this, there are many other questions that we will discuss later. Okay, hope you are all understood all these things. Okay, have a nice day. Thank you.